Okay, so this is the section on hypothesis testing for the mean this time. Okay, we've done hypothesis testing for the proportion, and now we're doing for the mean. So in your problems, you're going to be given a mean and a standard deviation, which you were not given in the proportion problem. So that's the main way you can tell the difference between the two. Okay, so I have the two formulas that we use for this, and please note that one of them is when n is greater than or equal to 30, and the other is when n is less than 30. When n is less than 30, you have to use one of the numbers on the t-distribution table. When n is greater than 30, you can use the ones at the bottom row. Okay, so that's the first thing you want to look for. There are a few notes on here that I'll probably be touching on as I go through these examples. You might just want to make sure that you read those again later when you are doing these problems. And then again, I remind you of the four-step process for a hypothesis test. And this is the same process that we had before. Same process, but of course we've got the mean and the standard deviation as part of our variables that we're defining. Okay, so example 1, then we'll go right into that. During the preparation of a canned soup, a machine is supposed to dispense an average, which is the mean, of 1,600 milligrams of sodium per can. The amount dispensed was determined for a random sample of 60 cans. The mean amount of sodium was 1,594 milligrams and the standard deviation was 19 milligrams. Again, that's of sodium. Is there sufficient evidence to conclude that the machine is not dispensing an average of 1,600 milligrams? Well, clearly this is not 1,600. However, statistically that might be close enough for our purposes to be able to say that it is actually equal. So we're going to test this at a significance level, which is alpha of 0.05. All right, we have a claim first. I don't have it written, but I'll write it now. The claim is that it equals 1,600. Okay, this is now we're using mu equals 1,600. So this letter is like a fancy U. It's not an M. It's called mu, and it represents the mean. Okay. This claim again was that there's 1,600 milligrams of sodium per can. So we have an equal sign. Because of the rule for the null hypothesis still has to have the equal sign, we'll put it right in there. And then the alternative then is just going to be a not equal sign, because we don't have a more or less situation going on. So this is what gives us two tails, yields to two tails. Okay. Now we're going to calculate, here are all the important parts from the paragraph. X bar, that's your sample mean. S is your standard deviation, your sample standard deviation. N is 60. And did have a few of you on the last quiz get these values mixed up. Somehow or another, you need to understand that N is the number, N for number, in the sample. Alpha was given as 0.5, and we'll talk about how I got this 1.96 in a moment. Okay, so because it's two-tailed, all right, I'll do that right now. And alpha is 0.5, we'll go to the table. Two tails, alpha 0.5, and then because N was 60, we're going to go all the way down to the bottom. And that's where the plus and minus 1.96 come from. So the critical values are negative 1.96 and positive 1.96. Those critical values indicate our reject regions. Okay. Then we're going to calculate this. So putting everything in the right place based on the formula at the top of the page. Again, I'll show you what that is. At the top of the page, X bar minus mu. Mu is coming from the null hypothesis. Standard deviation, this could be S. It's okay if it's S, or it's N. S and N are pretty much interchangeable for our purposes now. Okay, sigma and S are pretty much interchangeable. N is still the number in the sample. Okay. Now, like I said, everybody should practice with your calculator to make sure you can get that. Parentheses around the top, if you're going to do it all in one calculation on the calculator, you should add parentheses on the bottom as well this time. So 2 sets of parentheses. Or find the values separately and then divide, one or the other. One of the problems, though, with finding the values separately and then dividing is you shouldn't be rounding in the middle of the problem. Okay, so you may be tempted to round something in the middle of the problem, and then you don't have enough digits to have a very precise number. So then our numbers may be off when I'm going to check something. Okay, so I'm opening parentheses, 1594 minus 1600, close parentheses. Dividing. Opening another set of parentheses, 19 divided by square root. Okay, notice how the square root opens its own set. So we have to close it around the 60, and then we have to close again. So this is actually lots of parentheses. If you want to do it in just one. Okay, so we get negative 2.446, which rounds to negative 2.45. Okay, this is our test statistic. We compare our test statistics to the reject regions. We find that this falls in the reject region out here somewhere, negative 2.45. Therefore, we reject the null hypothesis because Z is in the reject region. So, rejecting the null hypothesis, we are rejecting that this is equal to 1600. Even though it's pretty darn close to 1600, we're going to reject that. Therefore, the claim is rejected also. So there's sufficient evidence to conclude that the machine is not dispensing an average of 1600 milligrams of sodium per can, because we had to reject the null hypothesis. Most of the procedures are the same. The formula is just a little bit different, but all the rest of the procedures are the same. It's just that calculating a different test statistic here, and perhaps using a different number on the table, which I hope the next one will be. Okay, I'm going to go to the back, and I'm going to look at example 2. Last year, the number of false fire alarms in a large city averaged 10.4 a day. In an effort to reduce this number, the fire department conducted a safety program in the city's schools. 6 months after completion of the program, a sample of 21 days had a mean of 8.1 false alarms and a standard deviation of 3.4. Does it appear that the department's program was successful? And we're testing at the 0.5 level. Okay, that's alpha. All right, so successful program means that they reduced the number of fire alarms per day. So our claim is going to be that the average is less than what it used to be, less than 10.4. Less than what it used to be, that means it was a successful program. Sorry? No. Okay, so here's the rule. The rule is that null hypothesis has to have the equal sign. Okay, so there's no equal sign in that claim. Therefore, the claim goes into the alternative. Now, the null, it can just be an equal sign, and I have noticed that the answers in your textbook give it an equal sign. But it can also be the opposite of your alternative and have an equal sign, so a greater than or equal to sign is also acceptable. So greater than or equal to is the opposite of less than. But the key is to put, if the equal sign is not in the claim, then that goes into the alternative. The equal sign must be in the null hypothesis. That is the rule. Okay. Writing down all of our other important information, we have a mean of 8.1, a sample mean, a sample standard deviation of 3.4. Our N is 21. All right, so that means that we have a t-distribution here. So the first thing we need to do once we recognize that we are below 30 is just due n minus 1. And of course, that's kind of, okay, that equals 20. Thought I had it wrong. And so that means we have a different place that we're looking at on the table for our reject region. So we're going to go to 20 on the table. It's one tail because it's a less than. One tail, 0.5 level, 20. So 1.725. So that's where this T comes from, 1.725. It's also negative because it's a left tail. So negative 1.725 starts our reject region. That's where the reject region comes from. Why that thing is showing up so dark? Yeah, Miss LePage. Better be late. Okay. So our reject region. Now we need to calculate again. Again, practice with me, guys. You should practice. You should practice calculating so you aren't surprised and don't get the wrong answer. Parentheses, 8.1 minus 10.4, close parentheses, divide, open parentheses, 3.4, divide, square root sign, close, close. Negative 3.099 or negative 310. Also, way out in the reject region. So we are rejecting the null. Now this time the null says that equal to 10.4 or greater than or equal to 10.4. So in rejecting this, we are saying that the claim is true. We're going to support the claim. So we reject the null hypothesis, and then we say there is evidence that the Department's safety program was successful. In other words, we support the claim. So this is a case where you're rejecting the null but supporting the claim. So it's going to work out properly if you get the signs in the right place. If you get the signs in the right place, you're going to be rejecting or supporting the claim correctly. Okay, I actually am going to do two more examples, and I'm going to do them from these two problems right here, these next two problems that, and then I'll let you do these three at your leisure just to practice, or I'll do them next time as practice, either way. Of course, you have some from the textbook you need to do as well. Okay, so I'm going to do a couple more here from scratch this time, showing you what it should look like when you're writing it down. Okay, the Boston Bottling Company distributes colas in cans labeled 12 ounces. The Bureau of Weights and Measures randomly selected 36 cans, measured the contents, and obtained a sample mean and standard deviation of 11.2 ounces and 0.38 ounces. Use the 0.01 significance level to test the claim that the company is cheating its customers. All right, the claim is the company is cheating. What does that tell us? There's less than 12 ounces in that can of soda. Okay, that company is cheating us. Okay, because there's no less than or equal to here, it's just less than, because equal to would mean they're not cheating. So if the less than is the cheating, then our null hypothesis has to be the opposite of that, or greater than or equal to 12. I will also accept a equal sign there. And that means the alternative matches the claim. Okay, the important things in this problem, we've got our null already. We need our n is 36, therefore it's large enough to use the z. Sample mean, which is x bar, is 11.82, and S is 0.38, alpha is 0.01. This is a one-tail, left-tail problem, so go ahead and draw your little reject region. Now we'll figure out where that reject region starts by going to the table, one tail, 0.1, all the way to the bottom. One tail, 0.1, all the way to the bottom. So negative 3.26, 2.36. Negative 2.326. All right, that gives us our reject region. Now we're ready to calculate our Z. Hopefully it didn't go off on the recording. Yeah. All right. So Z equals the formula x bar minus mu divided by standard deviation divided by the square root of n. Okay, so we'll go 11.82 minus 12 divided by 0.38 divided by square root of 36. Now, obviously it can help a little bit, you know, that square root of 36 is actually 6. So make the working on the problem a little bit easier. So parentheses, 11.82 minus 12, close parentheses, divided, parentheses, 0.38 divided by square root of 36 is 6, close parentheses, and we get negative 2.84. Not a whole lot bigger than where the reject region starts, but large enough. So into the reject region it goes. We are rejecting the null. So what does that mean? The null does not match the claim. We're rejecting the null, so what are we doing with the claim? We're supporting that claim. So what is this about the company? What's going on with this company? The Boston Bottling Company is cheating its customers, yes. Okay, so we're going to say since the test statistics Z is in the reject region, the null hypothesis is rejected. Okay, therefore, the Boston Bottling Company is cheating its customers. And that's a full problem. Doesn't take long once you know what you're doing. Once you know what you're doing, this does not take long at all. But you gotta practice. Gotta practice. All right, number 2, one more. In a study of factors affecting hypnotism, visual analog scale, VAS, sensory ratings were obtained for 16 subjects. For these sample ratings, the mean was 8.33, while the standard deviation is 1.96. At the O2 level of significance, test the claim that the population mean is not 10 on the VAS rating scale. Okay, so the claim is that the mean is not 10. That's all that says, is not 10. Now, because That's not an equal sign, that's a not equal sign. That claim has to go into the alternative, and the equal sign has to go into the null. This also gives us automatically a two-tail drawing with two reject regions.
So is the alternative always opposite the claim?
No, in this case it's matching the claim.
Yeah, I meant, like, is it always the claim?
Well, no, sometimes it's okay, I guess none of these examples had a claim with an equal to sign in it. If the claim has the equal to sign in it, then it matches the null. Because the rule is that the null has to have the equal sign.
Okay, so that doesn't count as an equal sign?
That's a not equal sign.
Okay.
Okay, so I'm going to pull the information out of the problem. Let's see, we have n equals 16, so what kind of test are we going to do? It's a t-test. Okay, so I went ahead and did my n-1. That helps me know what I'm going to look for on the table. Our sample mean was 8.33. Our standard deviation, 1.96. Alpha, 0.02. Let's see, we're going to get for this, we have to go to n-1 on the table. It's two tails. Okay, two tails, 0.02, down to 15. So 2.602. 2.602. And there's a positive and a negative, because it's two tails. So our t value is plus or minus 2.602. That gives us our reject regions. Now it's time to find the test statistic, which is going to work out the same kind of formula. So it's x bar 8.33 minus 10 divided by the standard deviation divided by the square root of n. Okay. So this is another case where we've got a perfect square as our n. So I can just go divided by 4 here. And we get negative 3.41. Negative 3.41 in the reject region. Okay. So we are rejecting the null hypothesis. And again, rejecting the null, but it's different from the claim, so we're going to support the claim. Reject the null, support the claim. Since the test statistic falls in the reject region, null hypothesis is rejected. And then your sentence needs to say, your next sentence needs to say something about the claim. So we are supporting the claim of not equal to 10. And if you go back to the question, population mean is not 10. Test the claim that the population mean is not 10. So we're going to say that the VAS ratings for hypnotism are not equal to 10. Therefore, the VAS rating for hypnotism, make sure I spell that right, NO, are not equal to 10. So again, just taking the words right out of the problem. So, not a very, again, once you practice, it's not going to take very long to get there.